Right, so let's take a look at what pointers are now. Now pointers are also user-defined non-composite data types, meaning that they fall into the same category as enumerated data types. But of course, they're not the same. They're two different data types. But what are pointers? To look at pointers, let's start off from what we already know, a simple variable. Let's say I start off by declaring this variable called x as an integer. And let's assume that the RAM looks like this on the right side. Right, it has a bunch of locations, 53 to 56, and you can store values in these locations. My choice of 53 to 56 is just an arbitrary choice that I made. So don't worry about why those numbers are there. It's just a random choice. But this is just how the RAM looks like. Now, when I declare x as an integer, if you guys recall what actually goes on in the memory, there would be some random location that is allocated to x in the RAM. So that choice is done by the operating system. So maybe the operating system decides, okay, let's give memory location 54 to x. So maybe x is now assigned this location. And by the way, 54 is x's so-called memory address. And everything else are also memory addresses for their respective locations. So 53 is a memory address, 54 is a memory address, and so on. But that memory location denoted by 54 is what we have allocated to x to store an integer. Now, there's a little bit more that goes into this allocation, specifically the size of an integer, because the size of an integer might change, and therefore you might have to allocate more than one location for an integer. But that's something we'll avoid for now. We'll assume that one integer occupies one memory location, as simple as this. Now, let's say I want to find out, actually I want to put the value 200 in this variable x. It's pretty simple, right? In pseudocode, what we do is we could say x arrow 200, and that way 200 would get stored at x, or specifically at memory location 54. That's what happens. Now, we're still not at pointers yet. I'm trying to get there, so hold on to your horses. We put 200 at x. Technically, the operating system puts 200 at memory address 54. But how the programmer knows this memory address is as the variable x. Now, let's say I want to find out what memory address x is located at, or where is this 200 stored. It's pretty simple. I can output a small circumflex comes initially, and then I can put x. So I put circumflex x. Circumflex is the symbol that you get when you press shift 6 on the keyboard. That's like the power symbol, but it's correctly called the circumflex. So you can find out which memory address 200 is stored at, or where x is stored, by doing circumflex and then the variable name, which in this case is x. And as you might have already guessed, this variable's memory address should therefore be 54. So when you run this code, you should get the memory address that x is stored at. And you can do this for an array, you can do this for a string, you could do this for something like a real, a boolean, whatever. You'll get the memory address where that particular data is stored. That's the idea. Now, outputting memory addresses like this is pretty simple, but our topic is pointer data types, right? So what if we want to store these memory addresses in a particular variable? So can I do something like, can I declare another integer as y maybe? And can I assign y to the address of x? Do you think that's possible? Okay, maybe it is possible, but if you look at this, notice how the data type of y is integer. But this is not technically an integer. This is a pointer or an address to a variable, right? So this is where the need for its own data type comes in, where we need to create our own data type for a pointer. So just to output the memory address of a variable, we can just say output circumflex x. But if you really want to store addresses or these memory addresses, not just to output them but to store them in a variable, that's where the need of a pointer data type comes into play. So the pointer data type is therefore a non-composite user-defined data type that stores the memory address of a value in memory or a variable, a value in memory or a variable. So the real purpose of pointers come into play when we can't just output them, but we actually need to store these variables or store these memory addresses in a separate variable. So how might we go about doing this? It's pretty simple, right? Let's take this step by step. The first thing I'm supposed to do is create the pointer data type. Just like any other data type that we discuss here, pointers are user defined. So you need to define to the programming language or to your compiler what this data type is. So that's why to start off in pseudocode by creating the pointer data type. Now how you create the pointer data type is a little weird. So let me write it and then let me explain it to you. So how I do this is by saying I do this by saying type, and then I would do something like, I would give this pointer data type a name. So maybe I can call this pointer P, and then I can set it equal to circumflex of integer. Okay, that's very odd, but maybe it's not too odd, but let's see what this means. Now we know that the circumflex gives us the memory address of a variable, gives us the memory address of some variable. So when I declare a new data type called P, that is apparently a pointer data type, and I assign it to say equal to circumflex integer, what it's actually doing is it's creating a pointer data type that is ready to store the address of some random integer, right? So the idea is I haven't really assigned it to any particular variable yet. I'm just saying, let me create a pointer that stores the address of some integer. The integer will come later on in the future, but let me just now for the moment create a pointer to an integer, and the integer can be stored later on. So that's the very first step, where you say type, the name of your pointer data type, then equals to circumflex, and then the data type of the variable you're going to find the address of. So I'm trying to find the address of x. The data type of x is integer, therefore I put integer here, right? So that's the very first step of creating a pointer data type. And then what I can do is actually create a pointer variable. Create a pointer variable. So how would this work? Now our data type is cleared. Let me create a pointer variable for x now, where x is the variable I was dealing with. Let's create a pointer variable just for our x. How this is done is pretty simple. I can do declare. Let me call this x capital P to denote x pointer, and then I can set this equal to, or actually colon, I'm sorry, and then say P, where P is the pointer data type for any integer, and pointer is this P is common for any integer pointer, but I'm specifically creating a pointer for xp here. So p is something general for any integer's address, but this is specifically for x only. So that's what I'm doing here. And then I can assign the address of x to xp, where x pointer will now get the address of x. So how that works is I can do xp is assigned circumflex x. X is the variable that stores the value 200. Circumflex gives me the address of this variable and therefore puts that variable's address into xp. So what would this actually store? If you look at the RAM diagram from earlier, it would actually store 54. So what we could just output straight away as 54, when we have to actually store it in a separate variable, do we have to go through this process of creating a pointer data type, declaring a pointer of that data type, and then actually going to assign it. So now xp would contain 54. And let's actually look at how these p and xp are actually created in the memory also. When I create a data type called p and set it to a pointer to an integer, nothing really happens to memory. But when I create a pointer called x pointer specifically of that data type for my x variable, then only would a space be allocated for my pointer in memory. So for my pointer to x, where point is just memory address to x, there would be a new memory location allocated by the operating system, and this would be xp in this case. And when I set xp equal to circumflex x, what actually gets stored in this memory address 56, which is again an arbitrary choice I made, is 54, where 54 is actually the memory address of x, right? Now notice xp is technically saying if you want to go to x, go to 54. And that's really why we call these pointers, because they are pointing to locations of other variables in the memory. That's the idea. So x is of type integer. The data type of x is integer. And the data type of xp is integer pointer. Not just any pointer, but integer pointer. We declared our integer pointer using the simple p letter, right? Okay, so now we've basically understood how pointers work, but I just need to clarify a few terminology of stuff that we did. But before I actually get to the terminology also, let me just describe one more thing that we can do with pointers. Now, we know how to assign the address of some variable to a pointer that we declared. Let's say I want to output the value stored at xp. Now, what is the value stored at xp? Oh, actually, let me not say stored, but let me say value pointed to by xp. So how might I do this? The value pointed to by xp is simply x, right? Because xp is x pointer, it's pointing to x. So technically outputting the value pointed to by xp is as simple as doing output x, where x is simply what xp is pointed to. But let's say I don't want to, I don't know that it's x, I don't know that xp is pointing to x. I just want to use xp itself to print out the value that it's pointing to. I don't want to refer to x, but I want to refer to xp only. So the way I might do this is by doing output xp and then circumflex. So when I put the circumflex before, it gives me or stores the address of x to some variable that is a pointer. But if I have a pointer and then I put the circumflex, what that will do is it will output the value at that address. So assuming that XP stores 54, which was the case earlier, because see, we stored the address of X at XP. If I do 54 circumflex for XP circumflex, what that will give me is basically what is stored at address 54, which is, in this case, 200, which is what is stored at XP. So the idea is this process of getting the address of a variable in memory is called referencing. And the second step of getting the value given in address is called dereferencing. Referencing is very simply address from value, and dereferencing is value from address. So the difference is basically the circumflex before with some variable to get the address from the value, and the circumflex after given a pointer to get the value from the address. So those are the basic terminology associated with the pointers and pointer data type.